We're going to start off this video by exploring zero exponents. So you may already know what happens when I raise something to the zeroth, and that something is that it's always equivalent to 1. So 2 raised to the zeroth power is 1, 3 raised to the zeroth power, 1, 7 raised to the zeroth, 1, 216 raised to the zeroth, 1. Pi raised to the zeroth, 1. Bob raised to the zeroth, 1. Anything raised to the zeroth power is always going to be 1. Let's go ahead and take a look at this idea in an equation. So if I look at this equation right up here, I'm thinking 5 raised to what power would be 1? So what would I replace this x with? What can I kind of put in that place? What am I hoping to put there? And it looks like it would be, well, 5 raised to the zeroth power would work. So if 5 raised to the zeroth power would give me that solution, then that means my solution, or x, is 1. Okay, let's go ahead and move this video over a little bit. Okay, let's look at this last question on this page here. So here I'm going to say, okay, well, 6 raised to what power would be 1? And when I kind of cover up all of that complex stuff and just say 6 raised to what power would be 1, well, 6 raised to the zeroth would be 1. So notice how I essentially just replaced, somewhat complex stuff, the 2x plus 3, that difficult looking exponent with 0 to get a true statement. And so if I can cover up that exponent with a 0 and get a true statement, then that means the exponent and 0 are equal. So 0 is equal to that exponent. Okay, let me just move that out of the way, and let's go ahead and write that out mathematically. So what did I just say? Well, I said that exponent can be replaced with or is equivalent to 0. And so once you get to that step, well, now we just have a nice, easy Math 1 equation. So I can go ahead and subtract 3 from both sides. And if I do that, I will be at -3. And then from here, I can just solve for x. So I can divide by 2. And then I will be at -3/2. And I can see that if I did plug in -3/2 for x in that top equation, 6 raised to the 2x plus 3 equals 1, then I would get a true statement. Because it would really be like saying 6 raised to the zeroth is equal to 1, which is true. All right, now we're going to take a look at other exponential equations when the exponent that makes the statement true is not necessarily 0. So we may have to think just a little bit harder. So in this first example, I have 5 raised to the x is equal to 25. So let's go ahead and maybe cover up that x and just kind of imagine it as a blank. So 5 raised to what power is 25? Well, 5 to the second would be 25. So I'm going to go ahead and replace that blank with a 2, 5 to the seconds. Okay, there's a couple different ways to think about this from here. You may just think, well, if I can replace the x with a 2, then the 2 and the x are equal. So if the 2 and the x are equal, well, then I just have my answer right there. So x is equal to 2. Now, sometimes when we get a little bit more complex examples, we're going to need to think about it in a little bit of a different way. So I'm going to go ahead and continue to stay on this left example, and I'm going to think about it a different way so it will help us for when the examples get more difficult. So I'm going to go ahead and keep this 5 to the x as 5 to the x, and my goal now is going to be to change the right side of the equation so that it has a base that is equal to the base on the left side. So essentially I'm going to think this. If I have a 5 raised to the x on the left, then I want the right side to be some kind of 5 raised to some power. Well, let's think about that. So how could I take 25 and rewrite it so it's still really 25, but rewrite it so it has a base of 5? So 5 raised to what is 25? Okay, so 5 raised to, well, the second would be 25. And now, when I look at the left side and the right side, they both have a base of 5. So the left side 5 raised to the x, right side 5 raised to the second. And so now if I really just focus on my exponents, after I know that I have a common base, well, if I have a common base, 5 raised to something, then those somethings must be equal. So once you get a common base, then you know your exponents must be equal, or x must be equal to 2. Okay, let's go ahead and see if we can apply this idea to our next example. All right, so let's bump this guy over, even keep my solution there and everything. Okay, so on this next example, let's go ahead and kind of reverse it. We'll still do both ways, but let's do this fresh new way first. So first I'm going to say, okay, we have 5 raised to 4x minus 3 is equal to, and what I'm going to be thinking here is I want to rewrite the right side so that it has a common base with the left side. So if the left side has a base of 5, then I want the right side to have a base of 5. So I essentially want to write 25 over here, but in a different way. How can I write 25 with a base of 5? Okay, well that would be a 5 squared, like we said before. And now that the left side and the right side both have a base of 5, well now I can go and set those exponents equal to each other. So you can only do this move when your bases are the same. So let's just go ahead and make sure that we understand that. So here our bases are the same, and there's nothing else going on besides a base raised to an exponent. So once we have a base raised to an exponent where the bases are the same, well that implies that our exponents must be equal. And then sometimes people get here and they get kind of happy because they're like, oh, I did a really hard move, so I must be done. But what are we typically trying to do? Solve for x. And it's no different in this case. So I'm going to go ahead and continue to solve for x here. So I'm going to add 3 to both sides. Again, I'm just going to show my work slightly more efficiently by just kind of showing that 3 is going to move over, or the negative 3 is going to move over. So I have a 4x on the left. I'm going to go ahead and add 3 to both sides. So add 3, and then 3 plus 2 is 5. And then my last move, divide by 4 on both sides, which is going to give me that x is equal to 5 over 4. Okay? Okay, perhaps just a little bit of a different way to think about this. Let's go ahead and give myself some more room here. Okay, maybe to say, well, let's go ahead and cover up that difficult looking exponents. And now let's think, 5 raised to what power would be 25? Well, 5 raised to the second would be 25. So I replaced that exponent of 4x minus 3 with 2. And when I replace that difficult looking exponent with 2, I get a true statement. So that means they are replaceable with each other, which means that the exponent of 4x minus 3 must equal 2. And then we can see, oh yeah, well that's just like the same thing that I was doing here. So I do my algebra and I would get the same exact answer. Just 2 different ways to think about completing the same problem. And just a couple more examples to solidify this idea here. Let's go ahead and take a look at this example on the left. So 2 raised to the x minus 14 is equal to 32. So one way to think about it would be to go ahead and just keep that left side as is, and let's rethink the right side. So the right side of 32, I want to say, how can I rewrite 32, still writing a value of 32, but writing it in a different way so that it has a base of 2, so that it matches a base on the left side, because the left side has a base of 2. Okay, so essentially I'm going to say 2 raised to what exponent would be 32? How many 2's would it take, repeated, multiplied together, to get to 32? 2 times 2 is 4, that's 2 of them, times another 2 is 8, times another 2 is 16, times another 2 is 32. How many was that? Well, that was 32. And if you want to see it written out, 2 times 2 times 2 times 2 times 2. Okay, 2 times 2 is 4. 4 times that 2 is 8. Times that 2 is 16. And then 16 times one more 2 would be 32. So then therefore I have 2 raised to the 5th, because it took 5 of them, to get me to that 32. All right, so now I do have similar bases. So since I do have similar bases, let's go ahead and set those exponents equal to each other. Again, I can only do this because the only thing I have so far is a base of 2 raised to something, and that's equal to a base of 2 raised to something else. So therefore, 2 raised to x minus 14 and the 2 raised to the 5th, well, my exponents must be equal. And then from there, I have a much easier question. So I'm not done, but I've done kind of all the hard work. So now I just need to finish it up. Okay, so I can go, add 14. And I'm just about there with a solution of 19. Okay. Okay, now let's go ahead and see if I can think of this same problem on the left here, but perhaps in a different way. So what if I could just kind of cover that up and say, well, 2 raised to what power would be 32? Well, we already were saying that was going to be 5, right? So 2 raised to the 5th power is 32. So essentially, I can replace the x minus 14 with 5. So if 5 and x minus 14 can be in the same position, then that means they must be equal. And so 5 and x minus 14 must be equal. Well, wait a second. Isn't that the same exact thing that we got right here? Yeah. So could you essentially think about that replacement and then go straight to this move? Yes, we can, and we will get the same answer. Okay, so why do we even bother with that other technique then? It seems like all the problems so far, we can just kind of use that cover-up technique and then set those two things equal to each other. Well, let's go ahead and take a look at this new example over here on the right. So in this guy, let's just try that technique real quick. Let's try the cover-up technique. So 4 raised to what power is 32? I don't know. Okay, so 4 squared. 4 squared, 4 times 4 is 16. That didn't work. 4 cubed, well, that's going to be 16 times 4. That's going to be way bigger than 32. So I guess maybe it's like some, fraction or perhaps a decimal, but it's not a whole number that's going to get me 4 raised to something 32. That's not going to be a whole number solution. So what happens is the cover-up method did not work. So it didn't work. We couldn't come up with a whole number. So we essentially need to use this other method of making my bases on both sides match. So let's think about it real quick. Right now the left side has a base of 4. The right side, could I write it with a base of 4? Is there a way to say 4 raised to something is 32? And that was essentially the same thought that we were just trying to solve, and we couldn't. So, okay, that didn't really work. I can't write the right side with a base of 4. But what about thinking of this left side here and seeing if I could do something with that? Well, what about 4? Can I rewrite 4 as maybe 2 raised to the second power? So 2 raised to the second power is 4. So I'd kind of just replace that 4 with 2 to the second. Well, what else is on the left side? Well, an exponent of x plus 4. Now let's go ahead and think about this right side here. So 32. How can I rewrite 32 with a matching base on the left? So the left has a base of 2, so I'm going to make a base of 2 here. And then 2 raised to something, well, 2 raised to the 5th would be 32. So then 2 raised to the 5th is going to replace the 32 on my right side. All right, now I essentially do pretty much have matching bases, but now I kind of need to attack all of my exponent stuff going on here on the left side. So I have an exponent of 2 and then raised to an exponent of x plus 4. So whenever you have a power, let me go ahead and highlight it here, a power or an exponent, a power raised to another power, I think that that's very powerful, and we're going to multiply those exponents together. So that's one of our exponent rules. When you have a power to a power, it's very powerful, and you multiply them together. So let's go ahead and think about what happens. So this is going to be 2 raised to the 2 times x plus 4. And times that entire thing of x plus 4. So we need to make sure that it's in parentheses. Okay, so now that 2 can distribute out. So that's going to be 2 raised to the, when it distributes, 2x plus 8, and that's equal to 2 raised to the 5th. Now finally, okay, I did a bunch of stuff now so that I have equivalent bases. So the left side has a base of 2 raised to something. The right side has a base of 2 raised to something. So now I can finally do this almost final move of setting the exponents equal to each other. So now I have 2x plus 8 is equal to 5. And we'll just finish it up with a little bit of algebra. So subtract 8 on both sides. Now I'm at a 2x, 5 minus 8. Well, that's going to be negative 3. And divide by 2 on both sides. We can write that in. So over 2 over 2. All right. And then finally we have negative 3/2 for my final solution.